final example in this section. Example number 4. Find the area of the region completely enclosed by the graphs of the given functions f and g. All right, so we have to, again, make sure that we understand which graph is greater than the other. If you were to put this in your calculator and this in your calculator, you would see that the graph of this one is above the graph of this one. So that means that the graph of f of x is greater than or equal to this graph of g of x. So in other words, when we finally are able to set up our definite integral, we're going to put this function first in that integral. All right, based upon these directions, you have to determine your points of intersection first. Your points of intersection will actually give you your limits of integration. So here's what I mean by that. First step, we're going to let f of x be equal to g of x. All right, y equals y. It's the reflexive property of equality. At this time, we're going to set it equal to 0 and solve for x. So we get this. I'm adding an x squared to both sides, and then I'm going to subtract 4x from both sides. So 2x minus a 4x is negative 2x, and then bring down the negative 3. Okay, hopefully this is factorable. And it is factorable. We get x plus 1, and then x minus 3. So therefore, the x coordinates of our 2 points of intersection that would exist based upon the graphs of these two functions would be what? Negative 1 and 3. These values are going to be your limits of integration. This is going to be your a value, and this is going to be your b value. So based upon those x values and the two given functions, and the fact that this graph is above this one, we will set up the following definite integral. Area is going to be equal to the value of this definite integral. Lower limit, negative 1. Upper limit, 3. Our functions we're going to put in here will be what again? Well, this one has to go first because it's above the other one. All right? The other one being your function g in this particular example. Okay, there's your setup. All you have to do now is evaluate this thing. So let's do that. So to evaluate this, we have to simplify what's inside of the brackets. So let's go ahead and do that now. We have a negative x squared, and then what? We have a 4x minus 2x. That's going to give me a positive 2x. And then we have a negative times a negative 3, which is going to result in a positive 3. All right, let's go ahead and integrate this now. We would end up with what? First term would be negative x, 2 plus 1 is 3, divide by the 3. Plus what? 2 times x, Well, if we add 1 to the given one, we get x squared, right? X squared over 2, 2's would cancel. This would be just then x squared, right? The antiderivative or integral of 2x is x squared, okay? And then the integral of a constant is just that constant times x. And again, we're going to be evaluating this based upon the lower limit of negative 1 and the upper limit of integration, 3. Let's see what we end up with. So here is what we end up with. And then we just have to compute the value of this expression, which would be 9. And then subtract off the value of this expression, which would be a negative 5/3. And so our final answer, therefore, would be what? 9 plus 5/3, which is the same as this. Again, please express your answer in fractional form unless you're told otherwise. So what does this represent? This represents the area of the region that's completely enclosed, all right, by the graphs of what? F of x equaling negative x squared plus 4 and g of x equaling 2x minus 3. All right? Hope you're having a great time. Hope you're staying healthy. Hope you're staying safe. All the best. Until next time, we'll see you later.